So we'll start here in like 2 more minutes. Let some people trickle in. At the same time, this is being recorded and it's going to be posted. But I appreciate you guys making it or finding the time in your day to day, especially with the last second announcement to make it to the actual workshop. Just a quick overview before we really get started here. So we're just going to be talking about machine learning, and like the pretty bare basics of it. We're not going to get too in depth. Um, So if you've taken like CECS 456 at the school, um, you're probably going to know a lot of this stuff already. If not, you should know all of it. If you don't know anything or something here, maybe you weren't paying attention that much in class or something. But this should be like a quick refresher. And if you haven't taken the machine learning course at Cal State Long Beach, I think this is a good introduction on what you would be learning in the course. At least like this is probably what you'd learn in like the first 2 weeks before you start getting into like the nitty gritty and like the math of it and stuff. Um, so yeah, that should give you a general idea. Um, and so I don't think it's necessary to really wait any longer. So just get right into it. So. AIX training. So we're launching these workshops that we're doing. We're basically teaching more people about AI, machine learning, data science, those kind of concepts all in one into a workshop program we called AIX training. This is the first ever rendition of it, or I guess edition, I don't know. It's the first ever workshop we have, AIX training, okay? And today we're going to be talking about machine learning 101 by me. I'm Shaun Lim. I'm the vice president of the AI Club. Um, and without further ado, let me think if there's anything else I should really point out before we get started here. Like I kind of said, I kind of went over what we're gonna be going over today. Um, yeah, well, let's just get straight into it. So, here's a quick overview. Um, Today we're gonna be going over the concepts and ideas behind machine learning. We're not really gonna get into like the math or implementation today. So if you're looking forward to that, I'm sorry, but this was really built for the people who don't really know what machine learning is even, and maybe even people who are interested in competing in the Datathon, but don't really know if they're really cut out for it. This is like this is the starting point basically. So we're gonna be going over what machine learning is, how does it work, and some different types of machine learning. And then at the end, I'm gonna wrap it up, and then we're gonna kind of go over what we're gonna talk about next AIX training, which is said to be bi-weekly, but I'm thinking of moving up to next week since the Datathon is coming or approaching so soon. I kind of want to get these workshops out there as fast as possible to really get people ready. But anyways, that's what we're going to be going over today. So let's just get it started. What is machine learning? Machine learning is a subset of artificial intelligence, if you guys may or may not have known, that enables computers to learn patterns from data and make decisions without being explicitly programmed. Meaning predictions can be made from unseen data. So what does that kind of mean? Um, uh, I would say that this is like a pretty wordy way to go about it and pretty confusing, and we're really going to be breaking it down more today. So if that doesn't make sense, I don't blame you. It barely really makes sense to me. Um, but usually it's kind of broken down into two different paths. We have machine learning and classical programming. And as you can see here, this is like something that I even or was talked about in my machine learning class and like some other YouTube videos that I watched to learn a little bit more about machine learning. And they say that classical programming is you create rules, uh think of rules being like if statements, while loops, stuff like that, and you take in data and then you return answers, right? Now, that kind of makes sense. And then this concept of machine learning, instead of making rules. Instead, you have a model make the rules after you give it a set of data and some answers. And this, to me, if this makes sense to you right away, you might be a genius because this, to me, when I first learned about it, I was kind of like, what? Well, that doesn't even make sense. What do you mean you make rules out of data and answers, right? And so let's get into that a little bit. So I have some examples for you guys. So we have traditional programming. Let's say a house price predictor. So in traditional programming, you would get a list of houses, right? And these houses have labels such as how much they cost, how many bedrooms, bathrooms, how many square footage, stuff like that, right? And then you add that to like a set of rules. Let's say down here I have a little example. I'm not sure if you can see my mouse, but I have a little, I'm pointing to the bottom left. An example of if a house is in the database, because this is our basically our house data set. If a house is in the database, return the house dot price, right? And if you combine these rules with a data set full of houses, you're gonna get a house price predictor if you give the exact values, right? But as you can see, this isn't really a predictor. This is kind of just a way of telling you what's in the data set in a more simplified version, as opposed to just like looking through that whole data set yourself. And so this is where machine learning can be pretty useful. So an example of this house price predictor in machine learning would be you have this data set of houses, right? Similar to what's up here. Um, but sorry. You have the sorry, I just choked up on something. You have this data set of houses similar to what's on the left side, where we have the square footage, stuff like that. And but now you add the house price at the end, right? And this was all mixed in the left side. The house prices are part of here in traditional programming. But just think of you have this data set of like square footage, bed bath, room numbers, and then now you also have the house price, and then you create this machine learning model. And what this model will be able to do is predict house prices um, that aren't inside the data set necessarily, right? It would still be able to predict house prices that are in the data set, but it will also say you give it a random house, it will be able to tell you what it thinks the price would be given the data that you give it. So, this bot right here says, according to what I've seen, this house should be worth around 600,000, right? And I'll go a little bit more in depth on this right here. But and soon, not right here, but in a little bit. But this should give you like a general idea of what machine learning models are kind of made to do, as opposed to traditional programming. I don't really like that saying traditional programming, but that's kind of like the two categories that they made up. So that's what we're gonna go with for now. So this next part, let me give you some more examples that aren't just house price predictors. We have spam detection, right? And so in this example, we have a list of emails, and we don't know like whether it's spam or not. And then each email that is given to the model is going to be labeled spam or not spam. And then the mixture of those two things will give us a model that is able to predict spam, right? That kind of makes sense. And I would say it's pretty intuitive. But now imagine something like a self-driving car, which is considered technically a machine learning model. Um, but now we're taking in stuff like camera images, LiDAR scans, or LiDAR scans, maybe. I don't even know how to pronounce that. Sensor readings, GPS data, past driving records, and then we're gonna add that with correct driving actions. For example, steer left, brake, accelerate, stop at a red light, stuff like that. And this is gonna give us a trained model that could drive a car. And that isn't very intuitive. How that model even works is kind of like, it doesn't really make sense. It doesn't make sense you would just give a bunch of stuff to a model and it'd be able to do all that stuff right away. And this kind of shows you like the two sides of machine learning, where there's really simple ideas in it and really easy stuff to digest, and then there's this whole other side where you kind of don't know what's going on, and this is where models kind of work the best. Because like honestly, for a spam detection model, like this is useful, but like you could probably make this without machine learning. Um, in some way, maybe look for some keywords that spam emails usually have, and then mark those as spam. Um, but and self-driving car, I wouldn't even that'd be like a billion if statements. So let's not even get started with that. But anyways. So how does it work, right? This kind of gives you an idea of what it is. Again, we have this example of traditional programming and machine learning. And now how does machine learning work, right? And so step one to machine learning is gathering relevant data. The more, the better. is a good saying for it. So we're gonna go back to our house price predictor example. Here we have this huge data set of houses, kind of like what I said. They're gonna have, it's gonna be labeled with how many beds and baths, square footage, the works, and then oh, sorry. We're gathering relevant data right now. So the whole point right now is to just gather as much data on these houses as you can. As you can see, this is one example of a house right here. Very poor quality, but yeah, I hope you could kind of make out what it says. It was built in the year 1951. Number of rooms 5, number of floors 1, lot size, yada yada yada. And then this right side is the most important side, I would say. As you can see here, we have the property type and then finally the sales price. Without this sales price, you wouldn't be able to predict what the price of a house could really be. Um, so just make sure that that's really ingrained in your brain that to be able to predict the stuff that you're training the model on needs to know what it's going to predict, right? And we'll get a little bit more into that. Not all models necessarily follow those rules, but it's a good rule of thumb, and something that if you're getting into machine learning is kind of easy to grasp. All right, so now that we've gathered all the relevant data, now we want to extract the relevant features. And this is probably one of the most important steps in like data science or machine learning or anything in that field. This is basically like 90% of the work, I would say, at least these days. And we're not really going to go over it that in depth because we're actually going to have like a whole nother workshop, like just talking about extracting relevant features. But for example, here are some features that we pulled from one of those houses, right? And say, okay, I want to feed this all this stuff to a model, but like, I don't know, is like the year that it's built really relevant to whether that will affect the price of the house? I don't know. Um, let's say it is, but I don't think the number of floors is very relevant. So let's just get rid of that feature. And property tax, I don't really care what the property tax is. I don't think that'd really be helpful to the model. If anything, I might think that might missteer the model and make it think the wrong things. Um, don't take me too literally. Obviously, I feel like property tax would be pretty important in a house price predictor. But let's just say, like hypothetically, I don't think property tax would be a good fit for the model for predicting house prices, so let's get rid of that. And then the current owner, that doesn't seem really relevant to me at all for predicting a house price, so let's just get rid of that too. Um, Sorry, let me do that real quick. And so this is kind of an example of like you want to pick the relevant features. And like this, there's kind of a whole art to picking the relevant features and like a whole thing called like exploratory like data analysis where you kind of visualize all the features and see how it maps in comparison to the data that you or the thing that you're trying to predict. And you don't really just go around picking, just straight off of intuition. I don't think number of floors would be relevant. Usually, there's some more like science behind it. But this is just an example. So that's what you want to do. Step 2, extract relevant features. Now, step 3, you start training the model on the features that you have, right? So now that I've extracted all the features from the houses, I don't want them to see current owner. Instead, I just want to see year built, number of rooms, lot size, and all this stuff, right? And then most importantly, sales price. Sales price is how we're actually going to be able to predict what's going on. And so we're going to feed this all to this model. Should we give this guy a name? I don't know. I'm gonna say let's not give this guy a name. Um, so this is gonna be our little machine learning model robot. And what he's gonna do now with after training is he's gonna be analyzing, finding relations between data and house prices, right? This is gonna be happening during the training process. As we're giving the model more and more data, he's gonna be doing this. And then, he's going to be thinking stuff like, oh, it seems like the number of bed and bath correlates with the house price a lot. Like if there's a lot of bedrooms and bathrooms in a house, the house price seems to shoot up, right? It's going to start figuring out those correlations. And oh, the year a house was built doesn't really seem that relevant. It doesn't seem to harshly affect the prices, right? So this is all just part of the example of what a training model. It's obviously not going to say these things. That'd be crazy. But it's on the inside while it's training, it's going to start realizing these connections between what we're trying to predict and the data that it's given. Okay. And so step four, evaluating the model. And this is another super, super important step, where I could probably spend the next hour talking about it. And we don't have the time today for that. Um, but as you can see here, just a little example. Say now that the model is trained, we find a house, a random house, right? And then we have the a list of the house features. This one's 4 bed, 5 bath, 4,500 square feet, etc. We give that guy, or we give this thing to the trained model, and this model is gonna make a guess. I think that this model is priced at 1.3 million, right? But the house is actually 500,000 because, like, it's in Nebraska and we didn't take that into account. So like what do you do now? Like that was like really wrong, and I want to fix my model. It doesn't really work. So things that we can do: modify the data, add more training examples, change the type of machine learning model we're working with, etc. There's like literally probably dozens to maybe even hundreds of things you could do to really tweak a model to be better at what you're trying to do. And obviously, like I said, we don't have the time for that today, but we will be talking about that soon. But this will give you like a general idea. This is the fourth step. You evaluate the model now. And the fifth and final step, you deploy the model. And this part we're not too concerned with right now. But just a little example. Our little guy is ready to start predicting house prices. And so where can he really be used, right? A house, just because he's ready to predict house prices doesn't mean really much. Like, where do you even use that, right? What's an example? And so here are a couple of examples. You could use them for real estate valuations, mortgage and loan approvals for banks. You want to know if you're trying to predict, like, there's a new house that was built, and then you're trying to balance basically what you think the house is really valued at versus how much money you want to give out as a bank. Pretty important. Property investors obviously want to know house prices, and urban planning. If you're a city and you have to build hundreds of these houses, maybe you could use like a house price predictor when you're building a house. I don't know. There's a tons of ways you could use this specific model, which should kind of show you how relevant machine learning is, like, this day and age. You could really probably find it everywhere that has to do with technology. Like, it, I wouldn't even thought. I was just looking up use cases for house price predictors. I didn't even think of urban planning. Like, I didn't think a city would like need a model or could utilize a model when doing something like that. Maybe all I could really think of is real estate evaluation, and even that, like, you would think you would have people out there specializing in that don't really need a model to do it. But at the end of the day, the beautiful thing about machine learning models is that they're like kind of like this never sleeping person that takes in one niche of information and kind of becomes a master at it. And like, no matter how good you are at evaluating prices as a real estate evaluator, let's say, you're not gonna be able to take in the same amount of data that a model that can train probably like millions and millions of examples in like a couple hours max can, you don't have that same amount of efficiency. So this is where machine learning models are relevant this day and age. And so if you wanted to deploy a model, you could find probably multiple ways or places you can really start. And so those are the kind of the 5 steps of how does machine learning work. If I just go back straight all the way back up to the top here, let's go past all these animations. Um, Step one, we want to gather the relevant data. Um, and the more the better. And this is really crucial. The data set that you're working with basically determines whether your model is accurate or not in what it's predicting a lot of the time. And then we want to extract relevant features, which is, I would actually say, is the most important, because all the features that you have aren't necessarily going to be crucial. And so the more you can cut down, the better your model will be. Then we have the model training part, right? This is where it's going to start taking in that data that you give it. It's going to start making those connections. Evaluating the model, almost as important as extracting features, except now you get to see what the output is and stuff. Now you could kind of really go in and see what you need to tweak. And finally, deploying the model. So that's a pretty good overview, I would say, of how machine learning works. And obviously, there's a lot of things there probably missing. But I would say this is a good umbrella that catches most of the cases of most machine learning models. But now we're gonna get into the types of machine learning. And this is probably the most relevant thing. Now that you guys kind of have an idea of what machine learning is, what it does, how it can be used, now let's kind of get into the types of it. So uh, here we have four types, right? Two are crossed out, as you can see, and I'll talk about those a little bit in a second. But the main two you should be looking at is supervised learning and unsupervised learning. This has got to be at least like 99.9% of the machine learning models out. That's why I kind of scratch out the last two. Reinforcement learning is kind of in its own subcategory of machine learning. And if you're interested in like a lot of you probably have already heard of like those like self-learning AI agents in like games and stuff, and like they get better with time. Probably seen like some YouTube video on that. And so that's an example of reinforcement learning, and that can be applied to many different fields and categories. And then self-supervised learning, I'll be honest, I'm not even too sure about what that is, but I always see it, and no one ever explains it to me, so I'm gonna have to do some research on my own. But just the fact that I barely really see it out there, besides on these lists of types of machine learning, I'm gonna tell you it's probably not too important. But if you wanna, strike a niche in machine learning, you should look into that. But today we're just going to go over supervised and unsupervised learning. So, first one, supervised learning, making predictions based on label data. So, just like our little house predictor guy here, he's going to take a list of house features labeled, right? And then he's going to tell you, oh, I think that this house is this price based on what I've trained on. And this label tag is, and I'll really harp down on this once we get to unsupervised learning, but this label tag means that the house price is labeled. That means we know or the house price that it was trained on, like the house prices that this model was trained on were labeled, meaning that when we gave all those houses with like square feet, bed and bath, room numbers, like how many room numbers, the year that the house was made. When we gave all that information, along with that information, we also gave it the house price of that house, and that makes it labeled. And I feel like this is really important that I really didn't talk about when we talked about what machine learning is. But and like I didn't really want to talk about it honestly because I feel like when I first heard of it this way, they just try to make it sound like it's like kind of like the simple math equation. And it was kind of hard for me to wrap my head around the first time, but uh the way that supervised learning works specifically is that we have this set of features, and then we have labels that connect to those set of features. And then from there, we're going to be predicting future labels given like a set of features, right? And can I annotate here? Oh, I actually can. Okay, let me annotate something for you guys. Uh, for the person in the chat who said, what's the difference between this and an LLM? Great question. I'm gonna get to that in a couple slides here, actually. So just stick around and I'll talk about LLMs and how this relates to that in a second. But basically, if we try to make like a little equation out of machine learning, right? So we have X, these are the input features, right? I'm gonna label this as inputs. Okay, we have X, these are the inputs. This is gonna be the 4 bed, 5 bath, 4,500 square feet. And then, yeah, that's what that is. And then we're gonna have Y, which is gonna be the outputs, right? And don't take this output as it actually like an actual output, but this is going to be kind of like the dependent variable. That's another way to mark these as independent and dependent variable. I really should use two different colors here, but it's okay. And this output is going to be the house price in this example specifically. And so this is going to be like, I don't know, 600K, for example. I said this one was like 500K, so let me do it accurately just for the sake of accuracy here. So given this, and this, we and also this in supervised learning, we give those all to the model, and that's what it uses to train. Um, and in this scenario, this is like technically an unseen piece of data, so that's why he predicts it incorrectly. But anyways, that's all besides the point. Let me clear all that off the screen real quick. But yeah, anyways, that's how they kind of do it, is that they say that there's like X, Y, input, output, and then using the input output pairs, we make a function f of x, and this is going to be your model right here. And basically, what this function will do is that when we give it new features, right, we put them into here, it's going to be able to predict a y based on the x's, okay? And the x's in this scenario again, four bed, five bath, 4,500 square feet. And then this y that it's going to output now is going to be, in this scenario, it was 1.3 million, okay? So that should give you a general idea of how they like to do it in kind of like a mathy way. But if you just want to get like the overarching concept, you don't really need to get into that right now. I would say just as long as you kind of understand what's going on right now, that's all that really matters. So yeah, anyways, back to supervised learning. We make predictions on labeled data like our little house predictor guy here. And there's two types of supervised learning. First, we have classification, where we categorize data into predefined classes. And so what does that really mean? Predefined classes? Well, let's see this example real quick. We have a bunch of independent variables here, and then we give them to a classification model. I like drawing, so I'm gonna keep on drawing. We give them to this classification model, and this model is gonna either put them into vegetables or into groceries. And here you can see that we have a categorical output for both. We have vegetables and groceries, and the model, tells you which one is which. So that's pretty, I would say, simple to understand. And if we go again here, this is just an example of, here we only have two categories, but not everything has to be two categories when it comes to classification. We can have multi-class classification. So here, let's say we give the model all of these pictures and we want it to predict what animal it is. So the model is going to be like, okay, I think this is an elephant. This is all very blurry, by the way, so I'm sorry about that. But okay, the model thinks this is an elephant, right? And the model's like, this is probably like a dog. I don't know. And then the models are gonna be like, oh, this is probably like a hawk. I don't know. And then I'm gonna think this one's a dog because all I learned is what elephants, dogs, and hawks are, and this looks most like a dog to me, right? And then it's just gonna keep on going down. Oh, this one's also an elephant. This one's probably an elephant, and this one's a dog, right? And so it could be classifying multiple classes. It doesn't have to just be vegetables, groceries, 0 or 1. It could be 0, 1, 2, 3, 4, 5, as many types of categories as you want. And so that's like a little idea of what let me delete all this here. Sorry. That's an idea of what classification is. And the other type of supervised learning is going to be regression. And so regression is used to predict continuous numerical values. Um, and so what that kind of means, that just seems kind of wordy. Our little guy here, he's actually a regression model, if you guys remembered. He's the one predicting house prices, and house prices can't be put into categories. It's just going to be a numerical value given this number of inputs. It's going to be like, okay, I think it's 600K, 650K, a million, 3 million. It could be anything in that huge range um, of infinite numbers, technically. And so that's kind of how regression models work. And he says hello again to everybody. And then here, this is kind of like a way to visualize it. Um, this is like the simplest version of linear regression, um, or of regression named linear regression, where we have these data points that we give it, right? And let me try to label this as specific things. Say that we're predicting house prices again, right? Let Y be house prices. So I'm just going to mark that as money. And then this is just going to be the number of bedrooms, right? So the number of bedrooms in a house. And so here we see, oh, this is pretty low, like 0, like 1 bed. So it's going to be low price. It's probably going to be like, I don't know, let's say 200K. And then as we increase the number of beds, the higher the price points get to be. This is going to be real expensive. It's probably like 10 beds, let's say, for example. And so given all these data points, we're going to make a line, right? And so what this line represents is basically how the model is going to choose to predict. So, for example, now let's say we give it the input of like 6 beds, right? And let's say 1, 2, 3, 4, 5, 6. Okay, 6 beds. Okay, now the model that it has this line to go off of, it's going to see, okay, we have 6 beds here, so let's just go until we hit that line. Okay, so we're on this line now, and let's see how much money that is. This is going to be, I don't know, 1.2 mil, for example. And so it'll output us this 1.2 mil uh because based off the 6 beds. And so that's what the line represents. Let me clear all this again. Um and this is like the simplest version of linear regression. And what we talked about with predicting house prices, we talked about stuff like number of beds, numbers of bath, like square feet, and then stuff that's not even really numerical, like, the name of the homeowner or something, or like what's another thing that's not numerical? Maybe the street name. And so you can't really put that all down on a graph, especially like this. And we're gonna actually have like a whole nother workshop talking about supervised learning models. And we're really gonna go into depth on how that stuff works. But for now, this should give you a general idea that regression is a type of supervised learning, sorry, that predicts continuous numerical values, like our house price predictor. I think I have some more examples for you guys here too. But okay, that's what regression is. Um, and so now we're gonna play a little game. For the people who are here right now in the chat, everyone try to respond. This should be kind of fun. I want you guys to basically guess if it's classification or regression, and you don't have to type the whole thing out. Just put a 0 or a 1. 0 being classification and 1 being regression, okay? Okay, so for the first one, a model that detects if a tumor is malignant. Is that 0 classification or 1 regression? Put it in the chat. So you guys are naturals at this. Okay. Yeah, classification, right? Classification, it's a tumor is either going to be malignant or benign. And if you guys don't know what those mean, benign means it's not harmful, malignant means it's harmful. And so easy, pretty a binary classification example there. There's really two outcomes. Okay, and so now this next example, a model that predicts what the temperature will be for the day. Is a 0 classification or 1 regression? And as you guys are good at this, obviously. It's all I see all ones, and it's gonna be a regression example. Obviously, temperature is measured on this numerical graph, and so it'd be hard to classify, 0, 1, 2, 3, 4, 5, all the way up to like I don't know if it could be like 130 degrees Fahrenheit sometimes. So obviously regression there. And so now, what about a model that recommends movies to you? Would that be like 0 classification or 1 regression? What do you guys think? I see some zeros. I see a 1. Okay. I see two ones. Okay. I see a 1 and a 0. Okay. And A. Okay. I like it. I like it. So this is where I kind of tricked you guys, right? Because you were all right no matter what you put, and you were all kind of wrong. Because um, there's you could do classification or regression for any type of these models. Let me kind of give you guys some examples here. Detects if something is tumor or malignant, right? How am I supposed to know? Say I'm not a doctor. How am I supposed to know if something's tumor or if it's malignant or benign? Sorry, if it's tumor or malignant. If it's malignant or benign, you know what would be better if if I could make the model give me a number from 0 to 1 scale, on 0 being uh what is it, benign, and 1 being malignant. Give me a number across that scale that kind of tells me what it's leaning towards, and then I can make that line in the sand myself on if I think if it's malignant or benign. So that could be technically regression if you try to, right? A temp what the temperature will be. The temperature, right, it's 0 to 100, but let's say I want to classify it as like hot, super hot, stuff like that. You could technically make classifications, right? If the temperature is between 0 and like 20, I'm gonna just mark that as cold. If it falls between that boundary, it's cold. So now there's a classification, or there's a class I can put that in. Those temperatures are cold. And then like 60 or 70, that's gonna be like lukewarm, you know? Um, and so a movie, or sorry, a model that recommends movies to you, you could really go either way. Zero classification, say that, okay, yes, this movie should be recommended, or no, it shouldn't be recommended, right? That's pretty simple, I would say. It's pretty intuitive. Or you could say, okay, give it a 0 to 100%, how much you think this rating is going to be, like how much you think the viewer is going to rate it, based on the previous movies that they watched. You think that this is like a 70% to them, or do you think it's like a 20% to them, you know? And so this kind of shows you how, like, just because what you see is either classification or regression doesn't mean it can't be like thrown both ways. And obviously, the tumor, obviously, it's easier to make that a classification model. For the temperature, easy to make it a regression model. And stuff like the movies, like I would personally lean more towards classification as well, but there's probably a damn good argument out there for why it should be, regression. So I just want you guys to keep that in the back of your minds as you're learning this stuff. But this should kind of ingrain it, classification or regression. But yeah, if the output is not continuous, then it's not regression. Yes. You're right. And that's another thing. I'm not sure if any of you guys have taken any stat classes, Stat 381. Um, but let's say I'm measuring the US national debt. Um, is that zero classification, one regression? I'll let you guys type in the chat. Should be a freebie, right? Zero or one, classification or regression? I see one, see another one. It's a one, right? But if you think about it, is the national debt continuous? What do you guys think in the chat? Do you think the national debt is a continuous, or is it technically not continuous? Isn't it discrete? And so wouldn't that kind of mean it's classification? Because the national debt is like what, 3.1 trillion right now, or something ridiculous. And like I would say that, okay, obviously large number, a bunch of, like decimals and stuff in there. Not decimals, but that bunch of decimal placements. Um, Regression, it's continuous, but it's not, because you can't go past two decimal points on the on the money sign, and like, you could probably calculate what the top end of that bound would be. And so that's something that was talked about in my statistics class that I thought was pretty interesting. Here it's a little different, because there we would talk about this continuous versus discrete examples, where obviously that'd be more of like a regression in this area, um, and like machine learning, because imagine doing classification for every cent value. If it's like, 1 billion and 2 cents versus 1 billion and 3 cents, you classifying those, that seems a little ridiculous. Um, you could have bounds on regression. That's true. Yes, very true. Um, but like depending on how you make those bounds, if I'm getting at what you're trying to say here, it can turn into classification technically, like the bounds on a continuous function. True, true, true. Sorry, I'm just reading the chat. But anyways, uh, I don't know. I just want to make you guys think about that a little bit. Hopefully that wasn't too confusing. And if it was, just ignore it. We have classification, regression, classification, groups, regression, numbers, if you want to put it as simple as that. Okay, so here, let's continue. So let's jump into all of the supervised learning algorithm. Let's go one by one here, okay? So first we have logistic regression. I'm just kidding. We're not going to do this today. Obviously, this would take too much time, and there's so much complexity behind every single one of these algorithms. Um, and these aren't even like these are the main algorithms. I'm not gonna say this isn't even like the bottom of the barrel of the algorithms. These are like the main ones. But there's so many more out there too. And there's no really real point right now when you're learning machine learning to really just jump straight into the algorithms. That might be the fun part. To me, it was the fun part, learning about how all this stuff works. But I think it's really best if you save that once you start implementing, and then you start learning about this stuff. So we're not going to learn about the supervised learning algorithms today. I'm just going to skip over that. And so now we're moving on to unsupervised learning. That was just all of supervised, unsupervised time. So this unsupervised learning, it makes predictions on unlabeled data. So if you guys kind of remember what I said earlier on what labeled data was, um, it labeled data, if I draw it out again, so this was an input, was it X, right? And these are the labels, or like these are the features, and Y is the labels, and Y is going to be the sales price right here, and then this is going to turn to F of X, which is our model. Is a pretty decent way to describe it. And so, and then I'm gonna do this as the label. So now, um, we're working with unlabeled data. So what does that mean? That means there's no more Y. We don't know what the sales price is anymore. All we have is just this list of house features that we're expected to use somehow, right? And so for predicting house prices, our guy's probably a little confused. How am I supposed to predict the price, he says? All the houses you gave me had no prices with them. And that's a great question. How are you supposed to predict the price? All you have is just a bunch of rooms and stuff, right? And so let me give you a different example that is actually how unsupervised learning works. This previous example would only really work for supervised learning where you had labeled data. But for unsupervised learning, let's say you get hired by some e-commerce company. Let's say you're working at Amazon. You just made it big. You're part of Fang. And they kind of task you, right? I'm gonna give you just a bunch of data, and I want you to figure out which customers are like the loyal customers that spend tons of money, which customers like buy sometimes, maybe they buy stuff on the holidays, and maybe they'd be more interested in discounts if they did that. The loyal customers, maybe we give them some type of rewards plan. And then can you point out like the new customers to me where maybe we send them more advertisements to get on our like, application more. And so all I'm giving you is a bunch of labels, right? So that's kind of like the breakdown. So here's a bunch of customers, here are their labels. Okay, I'm gonna give you their purchase history, browsing behavior, their spending habits, and like, their age and location. Um, and now what unsupervised learning does is now you personally are probably like, I don't know. I mean, like maybe the people who buy a lot right now are the ones spending, but I'm not gonna go through like the billion Amazon purchases just to figure out which customers are loyal, I'm just gonna feed all that data into an unsupervised learning model. So basically, we feed it to this model with the goal of finding patterns and matching groups, right? So here, our model says group one, these are the high spenders, given the data you gave me. Group two, these are the occasional buyers, they buy in the holidays. And group three here, the new customers. And so basically, the way that this model works is at least the main way, right? I'm not going to say this for all unsupervised learning, but this is the way I want you guys to learn it, is that unsupervised learning works by giving you a bunch of data and then the model will split that data up into different groups. And so here we have three different groups. And here's some more examples and better visualizations. If you focus on this right side with me here, here's the original unclustered data that we were just given, right? We take all the labels and then we start plotting the maps, and each one of these individuals is a different user, for example. And so now we have an algorithm that clusters the data based on, specific parameters that we give the model. And we'll talk about that a little bit more when we have our unsupervised workshop on the specifics on how it works. But this should give you a general idea that we could cluster the data in this way. And so here you can see we have three groups. You could think of this as the high spenders, and the new customers are down here, or maybe these are like the loyal customers, and these are the new customers, or like the occasional buyers, right? And another way you could see unsupervised learning split up is to uh, make it splits up into clustering, which is kind of similar to the example I just said, and association, where the model is tasked to find associations between different features, right? Maybe we want the model to figure out what the association between like um, let's say what purchase history plus age and location, how that relates to um, time spent on the website, Maybe we wanted to associate stuff like that. So that's another version of unsupervised learning where you're really just given a bunch of labeled data and you're kind of giving it to the model to just like figure it out itself. And then after the model clusters this data, this is where like the data scientists like you guys come in and you're really like, okay, I can see why I clustered this. These seem to be the high spenders, right? These are the people who are spending a lot of time on the website. These are the people I want to give like those promotions to. And then down here, these are the occasional buyers. These are the people like I want to give the discounts, so maybe that they'll come back more often, stuff like that. So that's kind of the whole idea between what the whole idea of unsupervised learning and how that really works. And then let's go one by one on what the unsupervised algorithms are. I'm just kidding again. Obviously, we'll have a different workshop on talking about a lot of these and the most important ones. Probably a lot of these you guys will probably never even hear of in your life, even if you go into a machine learning job, and because a lot of them are kind of irrelevant and they're for super niche areas. Um, but we'll talk about the main ones in a different workshop, okay? And so here's a quick overview of machine learning. We have supervised learning, which can be split into classification and regression, and unsupervised learning, which could be split into clustering and associations, kind of. And those are just two. Another one that it could be split into is technically like anomaly detection. For example, if you want to find like, if you're given a bunch of data and you want to find like someone who's like, um, a scammer or something, right? A scammer isn't going to be grouped up with all the other data. It's going to be like all the way out here. And so we're going to mark that guy as like, fishy or something. And so yeah. So here's our little guy. This is our regression guy. He predicts things, and those was the supervised learning guy. And then this is the unsupervised learning guy. And I group data or separate data. Separating data is kind of and grouping data is kind of the same thing if you think about it. But yeah. And so I have some questions in the chat, or I have a question because we're kind of getting to the end of the presentation here. I saw one guy asked back then, what's the difference between this stuff and LLM? And Keith kind of explained it pretty well. Um, LLMs takes text and numbers. Yeah, Keith had a beautiful explanation there. So you know what? I'll just leave that as it is. But what do you guys think? Is a large language model like ChatGPT, is that supervised or unsupervised learning? Zero for supervised and one for unsupervised. What do you guys think? Like ChatGPT, that's technically a machine learning model. Unsupervised. I see one supervised, a bunch of unsupervised. Okay, I like it. And why do you guys think it's unsupervised? Because I'll tell you right now, it's actually technically a supervised learning model. Um, And maybe I won't wait since we're getting kind of close to the time and or end of the workshop here on why. But let me explain to you guys why real quick. Why it's a supervised learning model. It's technically a gray area because you don't have to label the text. That's a pretty smart answer. But it's actually technically a supervised learning model because but the way that it works is kind of like it's kind of in that area of self-supervised because original language models, the way that they worked is that they took in inputs as words in a sentence, and then the labeled output would be the next word in the sentence, right? So there's like a beautiful video about this out there if you guys want to look more into how large language models work. But basically, it'll be like, say, you're given the input. Oh, sorry. Go ahead. Do you have a question? I think I think we're all good. Anyways, just me here real quick. Basically, it'll take like two words, say like what the, and then it'll predict what the third word is, and say in this scenario, it's like heck. So it's gonna predict like what the heck. Heck is the next word. That's kind of how it works, and so that's why supervised learning, the way that it's trained is also supervised learning, and the way that you fine tune models is definitely supervised learning because you need a lot of these input output pairs where you give it a data set and then you give it what you expect a large language model to say. Um, but unsupervised is not a bad guess. And I can see why you guys would say that because there's not really any clear labeling. But there are like techniques they use to label a lot of large language models. But yeah, all right. So we're getting kind of close to the end here, and I want to open it up for questions in a second. Um, And for next time, this is kind of an idea for our next AIX training. We're going to be going over Data Science 101, where the goal is to teach you about basic data exploration, some feature engineering, feature importance, kind of um, what I talked about a little bit earlier about the super important parts of training machine learning model, kind of like picking out the features correctly and then how to evaluate the model. We're going to be going over that a lot the next AIX training, and I would say if you're interested in data science in any way or machine learning in any way, I would say definitely try to make it to that because we're gonna try to give you guys like a hands-on walkthrough on Kaggle about this. And if you guys don't know what Kaggle is, we'll talk about it more next time. But it's basically this. this like website with a bunch of data sets on there and stuff. And some stuff for the future that we're gonna try to give out to you guys some resources before the Datathon is some workshop about supervised learning algorithms and specific ones like linear regression. There's k-means clustering. There's like SVM classification, stuff like that. And then some unsupervised learning algorithms like
Hmm?
k-means clustering was uh sorry, wait, did you want to say something, Keith? My bad.
Oh, no, my bad.
Oh, okay, all good, all good. Okay, but and then we have unsupervised learning algorithms. That's where the k-means clustering is. There's actually a k-means classification, I think, in the supervised learning algorithms. Anyways, we'll talk about all that more. And then computer vision. We never really got into um computer vision today, and it's because computer vision isn't really classified as a type of machine learning. Well, it is, but it's not really like the two main types of supervised or unsupervised. It's in its own category where it's like a type of algorithm almost, or kind of like subset where you can use it for supervised learning algorithms. For example, I'm going to give you an image of like this cat scan of someone's brain. Tell me if they have a tumor, and that's going to be a 0-1 classification. Or it could be unsupervised learning where it's like, okay, I'm going to give you a bunch of images of these people and like kind of group them up together and figure that out on your own, you know? So it's not really supervised or unsupervised specifically. It's kind of in its own subcategory, and that's when we start getting into like stuff like neural networks and stuff like that. And so that'll all be part of the future for upcoming workshops when it comes to Datathon prep. But yeah. I think that's it. Thank you guys. And I'm gonna open it up for some questions here. Does anyone have any questions about anything machine learning? And I guess before I open it up for questions, I'll dismiss you guys real quick. So, thank you guys so much for like hanging out. I appreciate like how many people are in here right now? It was a decent amount. Um, I don't know. I can't see right now. There's 15 people in here. Wow, I'm surprised. So thank you guys coming on like kind of like a late last second Monday night to listen to the workshop. This is all gonna be posted again on our YouTube. So if you want to go through and re-listen to some parts, hopefully I wasn't too confusing. Uh, it's kind of like a difficult concept if you're kind of like a freshman or junior or a freshman or sophomore and you don't really even understand the concept of artificial intelligence. It might be a little jump, but I think as long as you guys really start like cementing these ideas into your heads, and once we start working with them, I think it'll become like basically
Are
like
you
second
guys
nature.
ever gonna talk about Transformers?
Transformers, we will post Datathon. That's actually an AIX training that we're gonna talk about. We're gonna have a whole AIX training on large language models, and that's when we'll talk about Transformers.
Yep.
But
All right,
yeah.
cool.
But anyways, thank you guys so much for hanging out. If you don't have any questions, you're free to leave. But if you want to stick around for the last 5 minutes, and just kind of hear the questions and hear what people have to say, you feel free to. But again, thank you guys so much. I appreciate it. And you guys have a great rest of your night, all right?
I have a question.